So I'm going to talk to you today about server-side Swift and specifically with Vapor. So has anyone actually done any server-side Swift before? A few hands. Anyone done any Vapor stuff before? A couple of hands. Cool. Well, hopefully the rest of you find this interesting, and those of you who have done it will see some new stuff. So a little bit of introduction before we get going. I'm Tim. I'm a software engineer at the BBC. I work on the mobile playback team, and we make all of the kind of components that are common for playing back media across the BBC's mobile apps. So that's everything from managing downloads, DRM encryption, to the media player that plays back audio and video in things like iPlayer and News and iPlayer Radio and Kids and stuff like that. So that's kind of my day job. By night, I'm kind of better known as 0xTim across Twitter and GitHub and Slack and some of the Slack channels. And I spend a lot of my time working on Vapor. I started a kind of side venture called Broken Hands a few years ago, and these days it is exclusively doing Vapor work, whether that's consultancy, training, or freelance work, all on Vapor. And I do a lot of open source projects with them, and they've got a Twitter and GitHub as well, which you can visit if you want. And as Steve said, I'm an instructor and author at waywendlick.com now as well. So that's kind of a little bit of a background to me. So before we get going, what is Vapor? Vapor is a high-level framework for developing APIs and server applications written in Swift. So if you want a backend for your mobile app, you generally have a server, and you can write this with Vapor. So it kind of manages the dependencies between your databases using a package called Fluent, and that's kind of its database abstraction layer. And then you kind of have your HTTP calls from your clients, such as your mobile apps, your websites, etc. And also, there's a templating language called Leaf, and this is kind of similar to Mustache or Stencil, and this is how you can generate dynamic websites with Vapor. So my involvement with Vapor, Vapor was first created in February 2016. I got involved kind of not too long after that, in the summer when I started playing with it, but I never really kind of got into depth with it. And then Vapor 1 came out in September 2016. It was kind of like a stable, here you go, give it a go. And it was around Christmas that year where I decided I was fed up of writing in so many different languages. I've been using Python and C++ and JavaScript and Ruby, and I thought, I really like Swift, let's try it out and see what happens. So in Christmas that year, I created a project called SteamPress, because I was porting one of my websites over, and then I went down the kind of the scope creep black hole as you do as a developer. Thought, well, I want a blogging engine. There's nothing out there. How difficult can it be? And that was kind of 6 months of writing a fully featured blogging engine in Vapor. And it kind of became a bit of an example project for Vapor because there wasn't a lot out there at the time. And then in May 2017, Vapor 2 was released. And then I spent the rest of the year kind of writing a load of different other frameworks for Vapor, including Vapor security headers. So these add kind of common security headers to your server applications, such as CSP and HSTS. I've got quite a background in mobile security, so that's how I came about them. Vapor OAuth for doing OAuth delegation with Vapor, and Leaf Error middleware for doing custom 404 pages. And then in November, the back end of last year, I started work on a Vapor series, video series and a book for waywendlick.com on Vapor. And then April 2018, Vapor 3 has been released. It is currently in the process of being rolled out. So the first few dependencies have been tagged, and it's kind of being rolled out this week, which is going to make the live coding session great fun in a bit. So why server-side Swift? I mean, there's lots of established languages out there to help you write server applications. Why would you choose Swift? Well, for starters, you get to use Swift. And at least half the room should really like Swift. The other half are probably in the other building watching the Condon talk. So the whole room really enjoys Swift. It's a great language. It's modern. A lot of the languages that are popular with server-side technologies, such as PHP and JavaScript and Python, they've been around since the 90s. And programming's changed a lot since the 90s. And there's a lot of kind of tech debt that these languages are carrying around. So Swift has all these kind of takes all the good bits and throws away all the horrible bits. So it's a great modern language. It's also really safe. Swift is statically typed, strongly typed, which means that whole swathes of errors that you get in other languages just simply aren't possible. You're never going to get a null pointer in Swift if you program it properly. Whereas in things like JavaScript, you get undefined all over the place. And even things like Java, you have to check for null constantly. And that just doesn't happen in Swift. So it makes it a really good, stable language for writing server applications. So I've borrowed this chart off Tanner, who's one of the founders of Vapor. And on the kind of y-axis, you've got developer happiness, and this is how easy it is to get going, how much you enjoy your life, and then functionality down at the bottom. So if you're writing a mobile application, you're going to need a backend, because let's face it, every mobile app needs a backend these days. And if you may start with something like CloudKit, and it's really easy to get going. You can do some stuff really quickly, but you can't really do a lot with it. And as you need to change stuff, you go, well, actually, I need to do a bit more, so I'll try something like Firebase. And Firebase is kind of this middle ground between happiness and functionality, where you can do quite a lot with it, but not as much as you want to, and you can get going relatively quickly, but you can't get going really quickly. But as you add more and more clients, so if you add an Android app, if you add a web app, you find you kind of start duplicating all your back-end logic in your clients. So if you want to change the database model, you've got to change it in your Android app, in your iOS app, and how you interact with Firebase. And putting back-end logic in client apps is mental, because from a security point of view, it doesn't make sense. So you go, right, okay, I need something proper. So you go and pick Node.js, because it's flavor of the month, and you find that you can do everything you want to do, but your developer happiness kind of goes quite far down, because you have to write JavaScript. I'm not going to bash JavaScript too much. However, I suggest everyone goes and watches that talk. I'll post these slides on afterwards. It's a 4-minute talk about the ridiculousness of JavaScript. This came up on Reddit a couple of days ago, of just how JavaScript doesn't make any sense. And for some reason, people thought it would be a really good language to write server applications in. Balmy, no idea why. So you're back here, but what we found out is Vapor with Swift, you get to use all your tooling, you can use Xcode, you can set breakpoints and use debugging properly, and you kind of get to this thing where you can do everything you want to, but you're really happy. So we'll show some of that later. Another aspect, if you're kind of thinking about it from a performance point of view, if you look at Vapor 3, and this was pre-NIO, and I'll talk about what NIO is in a sec, Vapor 3 can handle, on kind of a standard benchmarking test, around about 120,000 requests a second, which is quite high. And its memory footprint is 8 megabytes, which is tiny. To put that into perspective, something like Gin, which is written in Go, that can handle around about the 100,000 mark. And Go is kind of one of these really top-end languages for performance. And its memory usage is low, not quite as low, but just as low. If we look at something like Vapor 3 currently, that's around 95,000 because of the introduction of NIO, and I'll talk about that when we get onto it. But the memory usage has dropped again. Compare that to Node. Node can handle about 60,000 requests a second, so still pretty good. But Vapor 3 is about 50% more performant. If you look at the memory usage, of course, you'll see that JavaScript, as anyone knows who's used Slack to heat their house, will know that JavaScript requires quite a lot of memory to be able to run. And then to finish this off, we'll look at Laravel, which is PHP. That's around about 1,000 requests a second with 2 gigs of memory. So there's a slight change there. So if you're a business, why would you use server-side Swift? Well, it simply comes down to money at the end of the day. If you need less memory to run your server applications, that's less servers you need. If you can handle more requests per second, you don't need as many servers. And one company who switched from PHP to Vapor have seen a reduction in about 85% of their AWS costs, which is pretty significant if you think about it, if you're coming from a business point of view. And it's also a lot safer. You're not going to have all these runtime crashes because someone sent you some really dodgy input, because Vapor and Swift can manage all of that for you. So why Vapor? Because there are other server-side Swift frameworks out there. So Vapor was started, as I said, in 2016 by a guy called Tanner Nelson, and then Logan Wright came along shortly afterwards. And it's kind of followed a similar development pattern to Swift. So with Swift, we had Swift 1, it came out, it was great, it was all fun, everyone got on board, and then Swift 2 started to change it as people got used to it, and how does this actually work? And Vapor 2 was very similar to that, of people using it going, well, this doesn't work very well, but this works great, and they kind of changed it to make it work a little bit better. And then when Swift 3 came out, it kind of rewrote the world, and everyone went through the great migration and hated it, and now we're on the other side. And I think Vapor 3 is going to be quite similar to that. It's been completely re-architected from the ground up. It's gone from a synchronous framework to an asynchronous framework. It's now completely non-blocking. So there's a bit of change there, but it lays the groundwork for the future. And Vapor 3 will be kind of the framework to use going forward, and it will be very similar in Vapor 4 and Vapor 5, hopefully. And it's built on top of Swift NIO. So Swift NIO was released by Apple only a few weeks ago now, and it's kind of their entry into the server-side Swift ring. It's a low-level asynchronous networking library, and it basically manages all of the interaction between HTTP and your kind of sockets and your connections through to the kind of your high-level stuff. So Vapor will talk to Swift NIO to manage all those connections, so you don't have to. There was a bit of a performance hit with taking this, mainly to do with the way that HTTP is parsed, but the Vapor guys are going to basically backport all their performance fixes, so you should see that performance number go back up. It's completely open source, Swift NIO, written by Apple. It's on GitHub. They're taking issues on GitHub. They're taking pull requests, which is pretty astounding, which is great, really good as well. So I've submitted a couple of pull requests, which is pretty cool. And it's the way that the world's going to go. And you need an asynchronous framework. It took less than 48 hours to integrate Vapor 3 with Swift NIO when it was released, which is pretty incredible if you're talking about switching out your entire networking stack. There was some forewarning that it was going to come, but even so, that's pretty incredible. And there were no major effects on the public API. So Vapor 3 was in RC1 at the time when Swift NIO was released. RC2 came out, and there were basically a few tries added, and that was pretty much it. So it was a bit of an Indiana Jones situation there, switching it out. So back to Vapor. It's modern through and through. Vapor 3 requires Swift 4.1, so none of this cruft of having Swift 3. You need Swift 4.1 to be able to build it. It's only just come out, so this is bleeding edge, but it is stable. CodeMobile is everywhere. If you haven't used CodeMobile, use it. You don't have to worry about checking weird JSON data, making sure this key value pair exists. CodeMobile will do it all for you. It's fantastic, and I'll show that to you in a bit as well. And it's a complete Swift stack. It's the only Swift framework that is Swift from the top to the bottom. So Fluent, which is the database drivers, all the database drivers are written in Swift. They're all non-blocking. None of the other frameworks have got that at the moment, all the way through to the templating language, which is Leaf, and that's written in Swift as well by the Vapor team. It's also the most popular, so let's get the ego trip out of the way. It's got the most number of stars on GitHub now, and it is growing at a rate of about three to four times the other frameworks in terms of stars. It's got that mind share and the community behind it. And related to that, the community in Vapor is fantastic. There is nothing like it I've ever used on any open source project. There are thousands and thousands of developers on the Slack channels, on GitHub, on Stack Overflow, who help everyone. It's a really friendly community and really good to get started. And it's always active. So if you post a question, you'll get an answer or 10 answers within an hour or so, which is great. So talk about deployment as well, because people worry about that, because you've got to manage Swift, and this is on Linux as well, remember. So Vapor will run anywhere Swift runs on Linux, and that's basically anything on Ubuntu. And so you can run it in a Docker container, so anything that runs Docker will run Vapor, which makes it really easy. So you can run it on AWS or Google Cloud or Heroku. The Vapor team also built their own hosting solution called Vapor Cloud, and this is built on top of AWS, and it's targeted specifically at hosting Vapor applications. So they've done a load of optimizations to make it easy to run Vapor. So if you have a Vapor application, you simply run Vapor Cloud deploy, and it will push it up to Vapor Cloud and make it really easy. And hopefully we'll show that to you tomorrow in the workshop if you're coming along. So downsides. So I've kind of hopefully sold Swift and Vapor to you, but there are some downsides, and we should mention them. The first is tooling. These are all related because Vapor and Swift are still quite young, especially on the server. The tooling isn't quite there at the moment. Xcode's integration with Swift Package Manager, which is the dependency manager for Linux, isn't fully integrated at the moment. Hopefully we'll see that this year at DubDub, maybe next year. Doing things like stat traces and bug hunting on Linux is still quite difficult, although not impossible anymore. Foundations, so you can use Foundation on server-side Swift, but on macOS you use the macOS Foundation, and this still uses mostly Objective-C, the Objective-C Foundation, and on Linux you use the full Swift stack because there's no Objective-C runtime. I won't get into that. There is no Objective-C runtime on Linux, and they're not the same. They're not completely equal. There's still some things that are unimplemented, and some things that don't work. It's a lot better than it was about a year ago, because a year ago it was pretty horrible. But now it's a lot better, but it's something to be aware of. The ecosystem is something that's not quite there yet either, because it's young. So if you want to get up and running with a web application. If you're using Node.js or Python or Ruby, there's thousands and thousands and thousands of packages out there to do anything you want, whereas Vapor doesn't quite have that yet, but it is coming. But it also means that if you want to do something, you get to build it. And there aren't many places you can build the first blogging engine or the first OAuth provider. So that's quite cool. And knowledge. There aren't that many articles out there. We're at the kind of weird stage that Swift was a couple of years ago, where if you can look on Stack Overflow, there's loads of answers for Swift 2, nothing for Swift 3. And there's going to be a bit of a weird transition phase. But the community's working on that. The documentation's coming. There's books and videos coming out, not just by me, but by other people as well. So it is building. So rather than just talk at you for however long, I thought we'll do some live coding, because how bad can it be? So we're going to create a new Vapor project, and the Vapor has a toolbox, which makes it really easy. So all you need to do is create a new project, is Vapor new, and then your project name. And then, because Vapor 3 is still kind of in beta, we need to pass it the beta branch. And this will basically clone a template and create a new project for you. And you create your project. So we can go into that. And then, because we're iOS developers, we want to use Xcode. So let's create an Xcode project. And this basically goes and grabs all your dependencies, same with if you're using CocoaPods, and will generate an Xcode project for you. One of the great things about server-side Swift is that your Xcode project is basically no longer needed. Obviously, there's no Xcode on Linux, and so with server-side Swift, your Xcode project doesn't get checked into source control, which means no more Xcode project conflicts, which is great. So once that downloads, let's have a quick drink. And hopefully the internet will let me download this. And the template's in a good enough state, given it's still in beta and rolling out at the moment. Hey, there we go. Cool. So this will generate your Xcode project for you. So I'll kick off a build, just because it can take a little bit of time to build the first time. So if we have a look at the Xcode project, you can see you've got your package.swift, and this defines your kind of dependency. This is very similar to your pod file for CocoaPods. And you can basically see we're going to pull in Vapor and Fluent SQLite, because it comes pre-configured SQLite. You then got your two different modules, and this is where all your code lives, and then you've got all your dependencies down here. And if we have a look in configure, this is kind of where all the magic happens. And you can set up different services, you can set up a router, different pieces of middleware, and your database. So we have a look in routes. So you've already got a route here, and this is basically defining a hello world route. So if you go to localhost colon/8080/hello, it will just return you hello world. And that's really simple, because all you want to do is return a string. If you look at a lot of other server languages and server frameworks, you have to mess around with setting status codes and manipulating responses and manipulating requests, when all you really want to do is return a string. And Vapor's got a really nice Swift API. It's been built with a kind of a view of integrating with Swift from the forefront. And it's a very Swift-like API, which makes it really easy to get started. So once that finishes building, I'll prove to you that it does work. Cool. And that will basically boot up, start the application up, because it's just a command line application, and then tell you it's loaded down here. So hopefully you can see that. So if we go to our browser, we can go to localhost colon/8080 and then /hello, and we get hello world. So let's say we want to change that and want to say hello to CodeMobile. So we can create a new route. So this is another route, and I'm just going to go to /hello/CodeMobile, and that will return hello CodeMobile. And it's really simple to get going. Let's say I want to say hello to myself, or anyone else who comes along. Now, writing everyone's names out would be inconvenient to say the least. So you want to be able to pass in a string. And to be able to pass in a string, all you have to do is string.parameter. And it will tell it to pick this up as a parameter. And then you can just extract the parameter from the request. And you tell it to do it as a string, and then you can just return the string again. And then you need to tell it what the return type is, because Swift, it can't really infer the return type because it's too complicated, apparently, for Swift. So if I then go to hello Tim, get hello Tim back. Which is really good. So let's say you want to do something with integers instead. So let's say I want to get the number of bottles. So like the string, you just use int.parameter this time. And then you can get out the count in just the same way. So I'm just going to say how many bottles I turn in. And so if I go to, there are 15 bottles. Now, if I was to pass in a string like this, what Vapor actually does is it will handle all of that parameterization for you. So it makes sure that that can be decoded as an int. And you'll notice that well, you won't notice actually because it doesn't say, but this closure is a throwing closure, and if you write it as a proper function, it throws, and there's middleware that will catch those errors for you and report back an error. So you don't have to handle that all for you, which makes it really powerful and easy to get going. So that's kind of how you do integers, but I want to show you something a little bit more complicated, which is interacting with a database. So I'm going to create a new class for a user. And then because Swift Package Manager doesn't really integrate with Xcode too well at the moment, you need to regenerate your Xcode project to pick up the new file. And it's a lot quicker because it already has the dependencies. So I open up the user.swift file. So I'm going to create a new class for a user. And I'll make it codable. And let's say we're going to have an ID that's just going to be an integer. And then we'll give it a name and a username. And let's give it just set up the initializer. So to be able to use this with our database in Vapor and with Fluent, I'm going to import Fluent SQLite because we want to use it with the SQLite database that's inbuilt. So to do all the setup to be able to save it into the database, to know what the column names are and what the table is going to be and how it's all set up, it's really complicated. You basically write an extension, or you can do it in time, and you just set it to be an SQLite model, and that's it. And that's all you do. And then now that this is written, you can interact this with your database. I'm also going to make it conform to content. Content is Vapor's wraparound codable and allows you to do such as setting whether it's JSON or form URL encoded. I need to import Vapor for that. And I'm also going to finally make it conform to migration. And migration is basically what gets run at the start of when your server application boots up. It runs all the migrations, and this is kind of your data in the database. So you have a migration for the user, which is the migration, the user table, and this will go and create the user table for you. And to specify all the column names, again, it's really difficult. You just specify it like that. And then you just need to add it to your migration list. So when the application boots up, it will create the user table if it hasn't run this migration before, set it up all properly, and then you can use it in the database. So that's pretty impressive. But how do we actually use this, interact with it? So let's create a route to be able to save a user. So I'm going to post some JSON to my application. I'm going to launch the rested application, which is kind of really simple GUI for sending stuff to a REST API. And we'll send it to users, and we'll send a post request. I'll make it JSON encoded, and then we'll pass it the name and a username. And so my request is basically going to contain this JSON payload. So to be able to decode this in Vapor, there's a number of ways you can actually do it, but they all use CodeMobile. And so making this is actually really easy. So I'm going to write a post request, and this .get.post denotes the HTTP method. I'm then going to tell it to decode my user model, and then give it the path as well. It was users. And then this will actually give me my user model, and we will return a user. And this will actually give me my user model inside the closure. So it does all the decoding for you. It handles any errors. If there are missing keys, there are missing values, or they aren't the right type, it will catch all of that and return a correct error to your client. So you don't have to do any of this at all. You'll note here that I'm returning a future user. So as I mentioned earlier, Vapor 3 is now asynchronous and non-blocking. So you kind of have to learn to deal with futures a little bit, although Vapor managed to hide a lot of that for you. So when I save something in a database, or when I retrieve something in a database, that request can take some time. So what Vapor can actually do is put that request down, and then go off and handle another request on the same thread, so you don't have to context switch between threads. And then when it's finished, it will pick it back up and handle the response. And this is what makes Vapor so performant. And until Swift gets a decent concurrency model, you're forced to deal with futures. So I've now got my user, and I'm going to save it and then return the result of the save. Luckily, the save method actually just returns the result, so I can just return that. So to save the user in my database, you need to create a save call. And that's it. There's no SQL you have to write. You don't have to interact anything with the database. It knows what database it's going into. And that's really simple. So if you want to get all of the users out of the database, so this one is going to be return a future array of users. QX code. So again, I'm going to write a query to get all of the users out of the database. And Fluent means that you have to write any SQL. You can just create a query and then call .all, and you get all of the users. And because it's using CodeMobile, it will create a JSON response for you and give it back. So the final thing before I demo this to you, mainly because it uses an in-memory database to start with, and I don't have to keep creating these requests because I know it's lunchtime. I don't want to keep people waiting, is getting a single user. So let's say I want to get a single user at /users/their ID. Now, you may be thinking that you're going to use int.parameter, and then you get the integer as the ID, then you have to make a request database, see if the thing exists, and then handle that case. Well, actually, you don't, because Vapor, again, makes it really easy. And what you can say is that the user model is going to conform to parameter. And again, you don't have to do anything, because Vapor does that all for you. And then you can just say user.parameter, and it picks it up. And then I'm going to return a future user, because it's got to get it from the database, remember. And so now I need to get that user out of the database, and I can just simply do that. And it's important to note here that if I wanted to manipulate this user at any point and just do like kind of and if I wanted to set the name or do anything like that, this is a guaranteed user. It's type safe. So remember, this is Swift, so you don't have to worry about, is this actually a user? Do I have to check everything? You're guaranteed that this is going to be a user, which makes Vapor really powerful. It means you do kind of all these errors that you get in JavaScript or Python just don't exist. So let's demo that. So that builds and runs. And if we head to rested, if I send my payload, you can see I get the user back, and it's a JSON body, because it sends the user back, and I didn't have to write any JSON code at all. That's all handled by CodeMobile. If I then change my request to get all of the users, you'll see I have an array of users, and let's just create another one just to make it a bit more obvious. So I have my second user, so if I get all of the users again, you can see I've got an array of users here, really simple. And then if I just want to get the first user, I'm going to get that. And I've kind of written almost CRUD API here for interacting with a database, retrieving, saving users in probably 10 minutes. I haven't had to write much code at all. And you'll notice a lot of the other kind of frameworks and a lot of the other languages, you need to write loads of kind of boilerplate code just to be able to interact with a database or be able to save JSON and things like that. And Swift with Vapor makes this really powerful, thanks to CodeMobile and because of Vapor's APIs. So that was the demo. So a quick recap of the code. To do any routing, you simply do .get and then give it the paths. So if you want to turn /hello, this gives you hello world. If you want to get an int, you can get an int out like that. And that's how you do integers. Models are the same, so you have a nice complicated user model. And then to make it be usable in a database, you can simply just make it conform to model, and it works. And if you want to use it with CodeMobile and be able to decode content from the request automatically with Vapor, just make it conform to content. If you wanted to do something like post it back in a form, you can just make it conform to content, and you just set the media type to form URL encoded, and Vapor will handle all of that as well. So it handles all of the decoding for form URL in content, encoded content as well. Saving and retrieving models. Again, you can call, there are a number of different ways of getting the data out of the request. Here's another example. Wrong button. There we go. You can call sync decode. So decoding in Vapor can either be synchronous or asynchronous. So if you're passing it, say, a file upload, and you're uploading a gigabyte file, you don't want to load all of that into memory, because Vapor doesn't need that much memory. So you can actually stream it kind of chunk by chunk, and that will return it in the future. But if you know that you're only going to be doing a small JSON payload, you can call sync decode and get that. Or you can actually just deal with the future. And we'll talk about that tomorrow in the workshop. And then to get all the users, you simply call .all on the query, because why wouldn't you? I'll talk quickly about Leaf. So Leaf is Vapor's templating language. And a quick look at how this works. So again, Leaf uses encodable. So because our user is codable, we can just give it to Leaf, and Leaf will know how to use that. But one important thing to mention is that you'll notice I'm actually passing a future array of users here, and then I'm giving that straight to Leaf. So you create a Leaf renderer, and then you tell it to render this template with the context. And Leaf can actually manage future types and streams. And this makes it really powerful because, A, it means you don't have to wait for all your things to come back from the database before you can start generating your kind of HTML page. And it also makes it really powerful because if you're doing something where you're switching on an if statement inside the template, so if you're on this page, grab all the users. If you're on this page, grab all the models, all the acronyms, for instance, if you're on an acronym page. If it doesn't actually go into that if statement, it will never execute that database query. So that's a kind of a massive performance gain if you're writing templating languages. And there are very few templating languages out there that have this ability. And this is kind of what the Leaf template looks like. It's a lot of HTML, and just kind of shows how horrible HTML is compared to Swift. But you kind of set the content, and then you can embed your base, and this is how you embed templates and other templates. And then you kind of got your if users, so if it's set, if you have any users, do this, otherwise just kind of show a nice message. And then you just simply use a for loop and loop through all the users, and then you can just use this kind of hash notation to extract out the ID and the username and the name. And because it's all codable, it just simply works. It's really, really powerful. So where to go from here? So now I'm going to do some shameless plugs. The videos are available on raywendlick.com now, all through Vapor 3. It covers everything from getting started, interacting with the database, doing everything, all kind of CRUD operations, including deletion and updates. It talks about how to do proper dynamic websites and web apps, so sending data to web applications to create stuff. And there's also an authentication module in there as well, so authenticating both an API and also a website with a login through a kind of login page. The Vapor book is available for pre-order now, as Steve said. It's discounted in the pre-order sale, I think. The early access chapters should be out this week, hopefully today, if the editors have finished their job and my writing isn't too bad. And the rest of the book should be kind of out, hopefully end of the month, maybe next month, depending on how much Vapor 3 changes over the next few weeks as it's kind of settles down and it's all written. Workshops tomorrow at 2 p.m. in Binks, so come along if you want to go through this. We'll go through everything we've done today, getting started, as well as some more stuff. Any questions? There is a microphone, yep.
Hi Tim, great presentation, thanks. I've played with Vapor and I love it, so I've got a million questions for you, but I'm just trying to think of the best one.
I'm here all week, so feel free
you'll get all questions, don't worry. Probably one of my pain points was something you touched on, which was when you deploy it onto your Linux deployment, it's trying to debug it while it's almost not in production. Obviously, you can deploy it in development mode, but it's trying to get access to what HTTP request was received by the server and debugging. I'm sure it's probably the same problem you have with other sort of web frameworks as well. How do you sort of and I just wondered, I was looking at logging and all that sort of stuff. Is that the approach that you would use once deployed?
Yeah, I mean, there's hundreds of different ways you can do it. The best way is to probably write a piece of middleware that logs out requests. You can write custom error middleware, so anytime you get an error, you can kind of catch that and then print out what the actual request was. You can print out the payload or send it off somewhere. And if you want to kind of do that, that's probably the easiest way. If it's actually crashing, there are tools out there for things like Bugsnag and be able to do stack traces, so you can kind of take your core dump and kind of give it up to kind of a bug website or something like that to be able to inspect it properly. But I think the rate of crashes we're seeing these days is actually dropping quite a lot, especially as more and more foundation gets implemented and people realize they shouldn't be force unwrapping optionals or tries. Crashes are kind of coming down. It's just generic errors that are being thrown. So yeah, kind of a logging middleware or error middleware to catch that would be great.
Cool. Any other questions? Yes, at the back. Oh, we'll go there first, then we'll come to you. Yeah.
Have you seen any big businesses take up Vapor, or is it just small startups?
So it's mainly a mixture of small startups because kind of all the indie developers who are, I'm an iOS developer, I need a back end, well, I'm going to use Swift because that's what I know. Certainly kind of at the BBC where I work, our back end teams are in a different city, let alone different building to where we are, and they're all Node.js. But we're starting to see more and more companies pick it up. There's one company called Nodes Agency. They're a web app agency based across Europe and in the UK and Copenhagen and stuff. And they're currently the main sponsors of Vapor. And they've gone all in with Vapor. And I think they have some pretty big clients, including Ironman and a couple of banks. And there's Taxi Hall app. And I think they see around about 15 million requests a day. And that's all running in Vapor and Vapor Cloud. And they're the company who've seen their AWS costs drop from 85% since removing PHP. And it's also worth noting actually that cost figure was going from them managing their own AWS servers to going onto Vapor Cloud and Vapor Cloud managing it. So there's a slight kind of price increase you pay for someone else managing it, but they're still seeing an 85% drop in price because they're no longer having to use PHP.
Thank you. So I'll go to the back first, then we'll come down. Sorry.
Thanks. My question is broadly related to that last one, actually, which is, I thought was really powerful was the benchmarks and the comparisons at the beginning. And I noticed that there were some common big enterprise ones that weren't in there, like Spring for Java and Web API for .NET. I'm just wondering if you know what the performance comparisons are for those.
So once Vapor 3 release actually is fully out, the team are planning to run a whole kind of suite of benchmarks across a load different frameworks, and they'll make all that public as well, so people can actually duplicate it and make sure the results are valid. I believe that Java is pretty good in terms of requests per second. Obviously, the memory usage is Java, so if you're on Android Studio, you know what that means. So I think it handles pretty well performance-wise, but its memory usage is pretty high. C# should be pretty good, but I don't actually have any figures. I can have a look if you want. But when the benchmarks are run, when it's released, they should be on there, and you'll be able to see those.
Cool. I have a second question, if I can.
Go for it.
Okay. I guess possession is 9/10 of the law. The second question is simply that last time I looked at Vapor, the database support wasn't quite what I was after. I was just wondering if that's been expanded.
So the currently supported databases are SQLite, MySQL, Postgres. There's first-class support for Mongo coming in the next couple of months or so as well. And there's also community drivers for DynamoDB, and someone is trying to write a MS SQL database as well. But if anything's got an HTTP API, which most things do these days, that's how you can do it.
Cool, thanks.
Cool. Any other questions? There was one down. Yeah.
What about Python?
Sorry, can you just say that again for the camera?
Yes. What about Python? How does it compare with Python? Because when I think of like modern startup-friendly language, I immediately think of Python. Like
So
it's easy to compare with the scripting language, PHP.
yeah, so I mean, the main issue with Python is that you basically got to run your code on the fly. So because it's an interpreted language, whenever you execute your thing, you don't actually have this compiled binary that you just run. You've got to have a Python interpreter that basically reads your code at runtime. So the performance is always going to be worse. There's nothing around that.
So it's very much worse in
I wouldn't be able to say if it's much worse or worse. I'd imagine it's somewhere around the JavaScript level.
Okay.
Or probably a little bit less, because JavaScript uses a CA HTTP parser. But it won't be anywhere near as good as a compiled language.
So the comparison you did with PhD also stands for Python.
Yeah.
Thank you. Anyone else? Yeah.
Thanks for the great presentation. I didn't know anything about Vapor before today. First, about futures. I really like that you use futures for requests. Is this an own implementation of futures, Vapor specific, or do you use some of the other?
So about 3 weeks ago, it was a completely Vapor-driven implementation. When Swift NIO was released, they've got their own event loop features, is what they're called. And so that uses Swift NIO's event loops. So if anyone wants to just write a kind of lower level server, you can just use Swift NIO, and if any of the other frameworks pick that up, it will all be the same kind of thing. And hopefully, as time goes on, we'll see Swift NIO hit Mac OS. I imagine it will replace CF networking in the coming years as well. So we should see that come across.
Thanks. And I really also love that as the routing and the query models, they resemble a lot Rails to me. I really, the best bits and really love working with Rails. So it was really nice. And can you say, if it's possible, quick word about transactions?
Yeah, so Fluent's got transactional support. So if you wanted to be able to do transactions, which is where you can kind of queue up a load of database queries and say, run this, run this, run this, and only execute all of them if they all succeed. Fluent has support for that as well. One thing I didn't actually mention in the presentation, I thought it had, is that Fluent uses key paths as well. So if you're doing a query between, say, a column name and an input, you can actually use key paths instead of stringly type stuff. And so it makes sure that if you're comparing a column name that's a string and you're giving it an int, the compiler will throw an error, rather than you getting that at runtime, which is another really nice feature. There's all these kind of nice things on top that make errors a lot less prone.
Thanks a lot.
One more question we'll take over here.
Keeping you all for your lunch, I'm sorry.
Sorry.
Hi. So as a mobile developer, part of what appeals to me is sharing a bunch of code between like the web and the mobile app. So like what you've got all there with the codable structs and stuff, all that seems really great to me. But can you use Fluent itself like in a mobile app? And is that something you'd recommend, or would you still be
so
using?
there's actually, I think it was yesterday actually, or the day before, there's a conversation going about making Fluent compile for iOS. It's a little bit tricky because some of the lower level dependencies require things that aren't explicitly available on iOS, but people are trying to make it work. And I think they'll probably be able to succeed. There's no reason why they wouldn't be able to. With regards to sharing code, you saw that I put all the kind of extensions for all the Vapor types in their own extensions. And the reason for doing that is to basically show that you can just take your model code and have that in a shared module that's accessible both through Swift Package Manager and CocoaPods, and pull that into both iOS and the server. And that's how, when the power really starts to come in, where you can be able to share your business logic and your models.
Cool. Thanks a lot.
Thank you very much. I think that's all the questions we've got time for, so please show your appreciation for Tim.